Welcome to today's lecture on Soldering Basics using the SD401 Soldering Practice Board. Today's handout includes a worksheet and this solder practice board in a kit. For some of you, this is your second time soldering a PCB. If you have already taken embedded systems, you would have seen a board like this, and this board has been completed, and today's solder kit is a practice run. For others, you may have never experienced soldering on an electrical circuit. On this board, all components except the LEDs, which are surface mount devices, are placed on top of the board and the leads are run through the holes and soldered on the bottom of the board, hence through-hole soldering. In the SD401 course, only through-hole components are allowed, so only through-hole soldering will be required. As shown, this two-layered PCB is made up of layers, a top layer and a bottom layer of very thin copper. 16.6 mils in thickness is pressed and glued to a thin sheet of material called FR4. This fire-resistant material, with a classifier of 4, is basically fiberglass, and FR4 is the most common PCB material used in the world, although there are many other styles. We're going to review today's handout. Along with homework 7, you're going to find this schematic diagram. Notice that TP4 is a PNP transistor, and it must be inserted correctly to make the circuit work properly. The emitter and the collector of a T4 and Q1 are reversed. The solder kit comes with a bag of parts. If some are lost, please ask for a replacement. The PCB has a top side, and to the left is a 16-position socket. This is actually a switch array. 4 of the switches will switch in different biasing resistors in the base circuit of the transistors. 4 for the NPN, 4 for the PNP. The idea of the board is to show by varying the resistance in the base circuit, the LEDs should change in intensity. Also, it is to show the transistors are either in the cutoff region, the active region, or in saturation. This is a picture of the printed circuit board. Notice the different size of trace widths. In SD401, you are to create your PCBs with trace widths of 20 mils for control and data lines, and with all power traces at 40 mils in width. Remember, the wider the trace, the more current the trace can handle. Once again, the bag has multiple parts. Some are lost, just ask for replacements. This is the parts list for this PCB design. Verify that all parts are in the bag. When installing your transistor, make sure to verify the components as they all look alike. Same with resistors. The switch should be installed with the numbers up. A PNP and an NPN transistor are functionally identical. They do different things, but you have to, the emitter and collector are switched. Tools required. Number 1, eye protection. It is NDSU and ECE policy that eye protection must be worn at all times when soldering, along with anyone in close proximity to you. Solder will splash and usually ends up in someone else's eye. When soldering is heated to a molten state, it is above 388 degrees Fahrenheit. You do not want that in your eyes. You only have 2 eyes and they need to be protected. This is a flush mount side cutter for snipping and cutting wire leads after the soldering process is complete. Make sure to snip the excess wire as it could bend over and short out to another component. A small needle nose pliers is available to the engineer when soldering. Another tool required is small forceps or tweezers. Usually, a curved tip is better than a straight tip, as it allows you to see the components being placed easier. Solder is now getting quite expensive, $56 to $75 a pound. Do not waste it, but use what is required. This half-pound spool of solder is made up of tin and lead. Designated 60-40 solder. Solder is 60% tin, 40% lead. At this time, we're still using leaded solder, but the time is coming shortly that an unleaded solder will be required. It is now a requirement in medical equipment, biomed, and other equipment as well. This 22 gauge solder has a diameter of 25 mils and has RA flux. RA stands for rosin activated flux and helps in the soldering process. A good solder iron is a must. In our labs, we use either the Weller brand or a SolderTech. SolderTech is made by the Pace company. As shown, you want to set the temperature to 650 degrees. 700 degrees if you are soldering with unleaded solder due to its higher melting point. Note the solder sponge. Solder sponges are used for cleaning the solder tip. This one is dry and ineffective to the user. Also, there are variation on tips. This currently is a conical tip on this iron and is preferred for general soldering that is done in the ECE labs. Here, the sponge is now wet and will help clean the solder tip, allowing the user to wipe the hot solder tip off on the sponge. The sudden temperature change allows the material that is oxidized onto the tip to fall off, leaving a nice shiny tip. A note to always set your iron to 650 degrees. Any more is not really required and burns the tips. Tips are about $5 a piece. The tip for this Pace soldering iron is $23. Adding solder to the tip before putting it away is good practice and saves the tip from damage. It's called tinning the tip. When soldering, as shown in this image, is a wisp of smoke. This is the rosin core or rosin burning off, and rosin prepares the board and helps clean the surface for a good metallurgical bond. Rosin flux is not dangerous, but we do have in the labs smoke absorbers in the labs if need be. They have a fan with a charcoal filter that absorbs the rosin flux. Here is an image of rosin smoke. It is not harmful or dangerous. The tip will be nice and shiny after adding solder to it. Now let's go and install the switch array on top of the board. Flip it over, solder on the bottom. Holding the solder pencil at a 45-degree angle, touch the PCB pad and the components pin at the same time. Within a second, add the solder until it melts and then move it away. Make sure to solder all the components. Here, 2 pins are left unsoldered, reminding you to always take a second look. Here's another look at trace width. A 10 mil trace cannot carry very much current. 40 mils, 4 times the amount of current. Even a 40 mil trace is small in width. When a component doesn't fit, sometimes you have to bend the pins and make it fit. You might have to bend the pins slightly. This is where a needle nose pliers come in very handy. Bend the pins, make it fit, solder it in place. Once soldered, you will have excess wire. Excess wire will be sticking out and could bend over and short out a component. So once soldered, you want to use the flush mount cutter to trim the leads. It's time to carefully place the rest of the components. The finalized solder board should look like this. You want to use a 9-volt battery or use a power supply in the labs to see if it works. Switch the varying biasing resistors and watch the intensity of the LEDs. What happens if you use too much solder and a solder bridge short circuits? How do you fix it? Shown here is a solder bridge. Here are 2 solder bridges as an example. How do we remove that solder bridge? Here is a solder pullet or a vacuum pump. Place it near the solder to be removed. Heat the solder with a soldering iron, and when it melts, snap the plunger. This sucks the solder away by vacuum. Sometimes this can damage a board with smaller traces. Here is some solder wick. This solder wick braid is used to remove solder. You want to trim the used end so a clean piece of braid is used. Solder wick is made from fine woven copper strands. Place the wick on the solder bridge and heat the wick with the soldering iron. You'll see the solder bridge is now gone. Done properly, unleaded solder is shiny to the eye. When you're done, be courteous to others, clean up after yourself. Put the shards in the garbage and put your tools away, making sure to shut the power off on the soldering irons. Along with the solder kit is a worksheet. This is the completed board. Please turn it and the worksheet in upon completion. The board will be returned.